Hi, hello, namaste. Welcome to Zenzi Learn. If you are preparing for coding interviews, placements, or Python programming, you are in the right place. In today's video, we'll learn everything about prime number interview questions. We'll be covering how interviewers ask these questions, how to identify the pattern, and the step-by-step logic, easy Python code, and the time complexity. By the end of this video, you will be able to solve all Python interview codes confidently. So without wasting any time, let's go started. Okay, before we start, before we start the topic called prime number, so why have I have chosen this topic is many of us practice coding by looking only at the topic name. For example, if we think I know prime numbers and move on, but in real interviews the same concept can be asked in many different ways. For example, from the prime number topic, interviewers can ask questions in 6 different ways. We could say that check a number is prime or not. This is first one, and next is prime print prime numbers up to n, and we also have print prime numbers between two numbers, count prime numbers in a range, find the next prime number, find the nth prime number. So these, if you practice only one version, you may struggle when the interviewer changes the question. So that's why in this series on Zenzi Learn, we won't just learn a topic. We'll learn every important variation an interviewer can ask. For each question, I'll explain how to identify it, the logic behind it, the steps to write the code, the Python solution, and its time complexity. So if you're preparing for placements or coding interviews, this series will help you build confidence instead of just memorizing code. Now let's start with the first question. Check whether a number is prime. Yeah. Check whether the number is prime. Right? Basically, this is a basic question which is asked in every interview. So that's why everyone will be knowing this question itself. So firstly, we'll be having steps in this. I'm going to say about steps. First step is just take the input. Okay. Nextly, you need to see that if the number is less than or equal to 1, then it is not prime. Right? If the number is n is less than or equal to 1, then it's not prime. This is the second step. Of course, we knew that a prime number is nothing but which is divisible by 1 and itself, right? So where we need to neglect 0 and 1, and so the below will be neglected. So next, the third step is just check divisibility from 2 to n minus 1. Check divisibility from 2 to n minus 1. So we have neglected here, right? So no need of including these two. We could start from 2. And next we have first step is if divisible by any number, then it's not prime. If divisible by any number, then it's not prime. Finally, we have otherwise it's prime. Right? These are the steps you need to follow while you write the code. And I'm gonna say also a logic for this. Logic. We'll be having basic logic for this. We already know that a prime number has exactly two factors. That is, it has two factors. That is 1 and itself. Factors are 1 and itself. Right? If any other number divides it, then it's not a prime. These are the notes for you to remember every concept. So that's why I'm spending this much time on this, writing the steps and logic. Okay. Otherwise, it's not. Otherwise, it's not prime. Right? Okay. Finally, we need to implement these steps and this logic into the code now. Yeah. So as we discussed in steps, we need to do code, right? So firstly, we need to take the input from the user. Enter the num. After entering the num, we need to check the condition. If n is less than or equal to 1, then it's not prime. Then you need to print it's not prime. Okay. Else, we need to have an else block here. We need to loop for I, which is in the range of 2 to n, right? Already we have taken here these two numbers 0 and 1, and the below numbers are not prime. We know that. So from 2 we need to check here. So if n modulo I is equal to 0, then it's also not considered as prime. Else, now we need to end up the loop if it's prime. So in else block, we will be checking if it's prime. Okay, it should be prime in else block. If it's coming to else block, it should be prime. Yeah. Sorry. Yeah, it's prime. So this is our code. First code has been completed. First question is completed. First, we'll be checking our second question. Second question is print prime numbers up to n, right? So in this also we'll be learning steps first. First step is, firstly you need to, the question is print prime numbers up to n, right? So you need to loop from 2 to n. This was your first step. Loop from 2 to n. And while coming to second step, for every number, check if it is prime or not. Okay. For every number, check if it is prime or not. If prime, then you need to print it. While coming to the logic of the code, instead of checking only one number, we check every number one by one. This was the logic of the code. Okay. Instead of checking only one number, we need to check every number one by one. Okay. According to these steps in logic, we need to build a code now. So taking input is common here. Okay. So I have mentioned here that we need to loop from 2 to n. So first we'll be taking for loop for n in range of 2 comma n. So n, it takes only the last part one number. So it takes last number which is not included. So you need to give n plus 1 which includes the last number also. So we need to have another for loop inside this. Of course, we need to loop from the other also. 2 comma n. Okay. So if n modulo I, the same logic we knew it, is equal to 0, then break. So after if, we need to write else here. Else print n. We'll be finding up to 10. Okay, 2, 3, 5, 7 are up to 10. So this is the second code. Yeah. So the time complexity for this print prime numbers up to n is O of n square, because we have taken 2 for loops here, right? I forgot to say for the first one, complexity here is O of n. Okay. So the second one we have completed. Now, while coming to the third one, we have print prime numbers between A and B. So this is the question now. So in this, firstly, as usual, we need to know the steps. First step is, we need to take A and B. This is the first step. And secondly, we need to loop from A and B. Okay. After looping, check every number. Check every number. After checking if it is prime, then print prime. Printf prime. Okay, these are the steps. And the logic, same as the previous problem, like only the starting point changes here. Okay, we'll be writing starting point changes. Okay, yeah, we'll be going to the code now. As usual, we need to take input, but this input is now A, right? And we'll be writing there's the number A. For B, same int input, enter the num B. Okay, so I have said you here, right? After taking input, we need to loop from A and B. For I in, let us take it as number, so num will be taking, not I. In range, so we have thought that we need to take from A to B, we need to count that. So from A to B plus 1, which includes the last one. So if num is greater than 1, this is the condition. If num is greater than 1, we need to take a for loop, because we have the prime number start from 2. So if the num is greater than 1, for I in range of 2 comma num, right? I in range of 2 comma num. If in case the same formula, if in case num modulo I is equal to 0, then break. Else, so when you're trying to end the loop, like if num modulo I is equal to 0 means which is not a prime, so you'll be breaking here. Otherwise, you need to give your statement in else part, so which need to be coming under the for loop, which ends the loop here. So 20. So, okay, we got the correct answer, right? Yes. So the time complexity for this problem is O B minus A into B. Third question is also completed. We'll do fourth question. Fourth one is count prime numbers in a range. Okay. Steps. First step is, firstly you need to initialize count to 0. Okay. We need to check in a range, right? So we need to initialize to 0. Actually, it was very similar to the previous codes, of course. So it doesn't affect your thoughts. Like it doesn't change immediately the coding. Right? Next one, check every number. And next, if it's prime, if after checking if the number is prime, then increase the count. Okay, then increase the count. Next, finally, you need to print count. Generally, if you want to count, or if you want to if you want to know how many values are there in there, so you need to use a count variable which need to be initialized first, and next you need to do incrementation by doing for loop. You need to increment everything, and finally you need to print the count. The logic of the code is instead of printing, increase the counter. This is the main logic. Increase the counter. Okay, this is the main logic here. Okay, we'll be going to the code now. This is the same. We'll be writing here. Same. We just will be modifying this. Okay. We'll be initializing count to 0 firstly. We took the input, we initialized count to 0. Why we initialized count to 0 is nothing but to count the values, the count variable is needed here. So to increment or to do some operations, a variable is needed here to store the values. So we have initialized that. So for loop, okay, from this range to this range, and a for loop, the num should be there. If num is greater than 1, for loop 2 comma n. If here, instead of printing, we need to increment the counter. Count is equal to count plus 1. Afterwards, you need to print the count. Okay, we start from 2, and with 20, we have 8. 8 prime numbers are in between the range of 2 and 20. Okay. The time complexity of this is same as the time complexity of before one. Take these steps, logic, everything as your notes, because anything could not be done after seeing this. If you take notes, if you learn from this, you could get clear identification of the things, and you could understand better even if you see once again after a few days. We have but one question is fifth one. Find the next prime number. So here they don't ask just find the next prime number. This question is also asked in such a way like what is the next prime, immediate prime after n, or find nearest greater prime number. Such questions can be asked. So this is a major main question which is asked in interviews. So which I found and which I gathered from the people who knew about the coding and the background things. So there's main things steps need to be included. First, we have questions from the next prime number. So we need to start from n plus 1. What do you mean by n plus 1? N is the prime number which you need to find. So n plus 1, if you start from n plus 1, it will be like iterating, it will be continuously checking next one after the one you have mentioned there. Like you will be mentioning a n number. So you need to find the next prime which is adjacent to the n. So you need to increment it. So firstly, start from n plus 1. Second step is check whether it is prime. Third one is like if it's not prime, increase by 1. Okay, if it's not prime, increase by 1. Because if it's not prime, you need to check the next number, right? So increment works here. Finally, repeat until prime found. Okay, these are the steps. Logic. Logic is simple. Just like keep searching until you get the first prime number. Okay, keep searching until you get first prime number. Okay, yeah. Well, coming to the code. Take an input first. here we don't need two numbers to be taken as input, because just we are seeing that what was the next prime number after the user enters the first one. So enter num. I have said you that we need to increment the number initialization. So we need to take a while true. While true is taken because it continues until the condition is true. It is a continuous one. So you need to check the next numbers continuously until you get the next prime number. So for I in range of 2 comma num. Okay, 2 comma num. If the general formula num modulo I is equal to 0. Okay, then break. Break means it's not prime. It's unnecessary to print it's prime or not. Here it's not necessary. So you need to break, and after breaking, the next will be, of course, it will be a prime. Else means it comes under it will be a prime. So then print the number. Then you break. After breaking, like if you found it's not prime, you need to do increment, right? Equal to num plus 1. We could also write a shorthand form here, which is num plus or equal to 1, which is a little bit confusing. So that's why I use a general method, num plus 1. So we'll be running it. Take 3. 5 is the next prime. Okay, we have completed fifth one also. And the time complexity for this question, finding next prime number, like it depends upon the gap between the primes. So we can't decide what is the time complexity. Just I'm writing for your clarity. It depends on the gap between primes. Okay. And finally, we have sixth one, the last one. Find the nth prime number. And this could be asked like not any nth. This could be asked like find the fifth prime number, nth prime number, or kth prime number, etc. The questions can be asked in any ways, but the method would be seen for the each and every question. Steps firstly, firstly you need to start from num is equal to 2. Okay, start from num is equal to 2, and next count every prime. Finally, when count becomes n, when count becomes n, which is the user's input, then print the number. Num. Okay. Okay, logic. Logic is nothing but just keep checking numbers until the required number of primes is found. Just check, keep checking numbers. Keep checking numbers until the required number is required num of primes is found. Okay, that's it. And finally, we need to do code. So taking input is okay. We'll try it from starting. So we need to first initialize count to 0 and num to 2, which need to be started from 2. Okay, and I have said that we need to use while loop for continuous checking until, sorry, yeah, for I in range 2 comma num. If num modulo I is equal to 0. Then you need to break else count is equal to count plus 1. Okay, and in this else also, after incrementing the count, so if this count, if count is equal to n means the number which the user have entered here. So nth prime number means what is the fifth prime number if he asks for the fifth one, and the count is at the fifth position and it is equal to the n number. Then what you need to do is print the number. Okay, the number at the nth position will be printed. Then you can break the if condition, and finally if not you need to increment, right? Yes, if not you need to increment. You need to know second prime 3. Okay, the second prime number is 3. Like, finally we came to the end, the time complexity. Like we could say that approximately O of n square for this basic approach. We could say that O of n square.